Bienvenidos, Ushamdi, and welcome CTS-131, Section 875 students for the Spring 2018 semester at Anne Arundel Community College. This is the Cisco Networking Academy Routing and Switching Essentials version 6 course, and this afternoon's Packet Tracer tutorial and solution set is going to be on Packet Tracer Activity 5.2.2.7, where we take our first look at switch port security and how we can secure our environment from a layer 2 perspective. And again, remember, layer 2 being the data link layer, and the protocol data unit is the frame, and the addressing that we are interested in at that layer is the MAC address. And so that is what we are going to be focusing on here. So let's take a look at our activity. Again, a very short activity, a nice activity to sort of get us warmed up here in terms of what port security is all about. As you can see over here, we've got our addressing table, as we normally do in the top center. We've got two PCs, a switch, but then we also have a rogue laptop. Now, everybody is going to be in VLAN 1. In fact, I believe our next unit is going to be all about VLANs. However, right now we're dealing with a single VLAN. In fact, this switch right here, switch 1, you could assume that this was taken from its box, plugged in, and then the PCs have been connected to it. Again, by default, every port, if it's an access port, is going to be a member of VLAN 1. And so let's dive in and see. We're going to configure port security, but then we're also going to verify port security. So configure port security part 1. So step A is access the command line for switch 1 and enable port security on fast Ethernet ports 0, 1, and 0, 2. And we can assume that these are the two ports, fast Ethernet 0, 1, and 0, 2, that PC1 and PC2 are connected to. Now, I'm assuming that we are going to have to, let's see if we can access the CLI here. And we can. All right, so let's make this a little bit larger. We'll come down just a skosh. So here we are in the command line. We're in user exec mode as evidenced by the greater than sign. When I type enable, that's going to transition me to privilege exec mode. Now, we're going to access the command line and enable port security. So let's go into global config and let's use our interface range command, because we're going to be making changes to a range of addresses, specifically fast Ethernet 01 and 02. Now, both of these ports are already up, and so how do we enable switch port security? Well, there's one command that is required. It is mandatory that if we want switch port security to run, that we issue the command switch port security by itself. So no options are required here, but we must have this command by itself, or it is not going to turn switch port security on, irrespective of all of the other switch port security commands that we may put in. So in other words, that command is a requirement. Now, we're going to set the maximum so that only one device can access the ports. Now, switch port security, and if I do a question mark here, you can see that we've got a limited list of options from which to choose. We've got MAC address, we've got maximum, and we've got violation. And we'll touch on each of these in turn. So right now we're interested in the maximum. And what we're saying, when it says the maximum number of devices that can connect, it's the maximum number of MAC addresses that this port is going to allow to be seen. So I'm going to say switch port security maximum, and you can see that I can choose between 1 and 132, and it's maximum addresses, and the address is not an IP address. We're talking about layer 2 security. So the addresses that are being referred to here are your MAC addresses. These are the 48-bit addresses that we find at layer 2. This is very different from an IP address that is a 32-bit quantity with IPv4, 128-bit quantity with IPv6, but we find those, both IPv4 and IPv6 addresses, are at layer 3 of the OSI networking model. So here we're going to say 1. Now, I'm going to be interested to see what comes back. Now, we're at 32 out of 100, and I'm curious to see how the engine treats this, because this is the default. So by default, the maximum number of addresses, if I enter no commands in, the default is 1. So let's see if we get scored on this and if we receive any points. And we do not receive any points, so we're still at 32 out of 100. And so again, I was interested to see, it says set the maximum so that only one device can connect. Well, I don't actually have to enter that command. That is the default. In fact, if I was to say do show run, this typically comes up, and this is a common point of confusion for learners, is they enter the command, they do a show run, and then they see that the command that they just entered is not being reflected in the running configuration. And so this can be a concern because you may think that the command that you just entered in, maybe you typed it in wrong, maybe you got the wrong syntax, but the parser simply didn't give you an error. Wherein the true problem is that it's a default configuration setting, and even if we enter it in, the running config is not going to display it. It's not going to reflect something that is the default configuration. Okay, so that's step B in part 1. Now let's take a look at step C. Secure the ports so that the MAC address of a device is dynamically learned and added to the running configuration. Now there's some key words here that we need to focus on. Dynamically learned and running config, right? Because what I could say is I could say switch port, port security, and MAC address. And as you can see, I can actually manually, as opposed to dynamically, I can manually type a MAC address in here and hard code that MAC address onto the port for switch port, port security. However, what does our keyword say in step C? It specifically points out dynamically learned and added to the running config. Now, we want to make sure that this gets added to the running config and the sticky meets both of these requirements. So not only is it going to dynamically learn the MAC addresses upon the first frame entering the switch port from the PC, the in node, that's how it learns that information. So now if I say switch port, port security, MAC address sticky, and I say do show run, you may be saying, well, hold on a second, Travis, you just told me that by putting sticky in there, that it's going to learn that MAC address, that layer 2 48-bit address, and that it's going to auto-magically add it to the running config. So your question is, where is it? Why is it not there? Remember what I just said previously. Upon the first frame entering, the first frame to come into the port into which the PC in question is connected. So, for example, and let's change to red here, PC1, the first frame that shows up from PC1 on that switch port right there, then the switch will automatically learn that MAC address. And until that happens, there will be nothing in the running config. And the same is true of PC2. It won't be until a frame shows up, a layer 2 frame, where the switch will look into the source and destination fields, and specifically in this case, the source field, and it'll say, who is the source, what's the source MAC address for this layer 2 frame? And it's based off that information that it then refers to that sticky argument of the switch port, port security MAC address sticky and says, hey, I've been instructed that the first frame that I receive on this port, I'm going to look at the source address, and that is the entry that I'm going to stick to the running config, that I'm going to stick to this port. And that's how port security is functioning. So let's take a look here and let's see, since I've been talking, has anything sort of been automatically generated? It hasn't. And let me take a quick look. I'm assuming, yeah, okay, so they want us to ping, and I'm going to wait to set everything up here before I ping. Because you're probably saying, well, just run a ping between PC1 and PC2, and that's absolutely what we're going to do. However, I'm going to wait until we get to the step that's going to ask us to do that. So from PC1, ping PC2, we'll do that here. Now, when we take a look at D, step D in part 1. It says set the violation so that the fast Ethernet ports 01 and 02 are not disabled. In other words, are not shut down when a violation occurs, but a notification of the security violation is generated and the packets from the unknown source are dropped. Now, there's 3 types of violation action that we can take on the switch. We can shut the port down, and that is the default behavior. And notice here that it's saying that that is not supposed to happen. We can restrict the port from a violation perspective. And what restrict means is it's going to drop the unknown traffic, the traffic from the unknown source, and it is going to generate a message, but it is not going to shut the port down. And that's restrict. And then there's protect. And protect does everything that restrict does, except it does not generate a message. And so those are our 3 choices: protect, restrict, and in fact, if I was to say switch port, port security, violation, question mark, you can see protect, restrict, and shut down. And it's kind of ironic that these are in alphabetical order, and if we go from top to bottom, they are also listed in order of severity in terms of the action that they will take if a violation occurs. And so you may be asking, well, what's a violation? Well, remember, we said that the maximum number of MAC addresses that are allowed to appear are 1. And as soon as it learns it, if any different MAC address from the one that it has stuck to the port shows up, that is a violation. That is what port security is all about. So again, from top to bottom, protect, restrict, shut down. Protect will drop the traffic from the unknown host, but it will not shut the port down, and it will not generate a message. Restrict will not shut the port down, but it does generate a message and drops the traffic from the unknown host. And then shut down, which is our default. Shut down will literally air disable the port, and the port is in effect shut down. And there's manual intervention by default. There's manual intervention that's required to then bring that port back online. So we're going to say switch port, port security, violation, restrict. And we should see a bump in the points, and we do to 62. Now, disable all remaining unused ports. And it says hint, use the range command. And that's a pretty nice hint, because if you didn't use the range command, show IP interface brief, I think we're 24 ports and then 2 gig ports, and we're using only the first 2. So if you didn't, this would take forever. So interface range, fast Ethernet 03 to 24, gigabit Ethernet 01, whoops, and I'm going to rerun that again, 01 to 2. And we're going to say shut down, and we'll see if we move off of the 62 points that we currently have, maybe add in a few more, and we added quite a few in there, about 24. So it looks like 1 point per port to shut those down, so we're now at 86. So here's what we're going to do now. From PC1 to, we're going to ping PC2 from PC1. And again, before we do this, let's take a look at our running config. We can see that, again, it gives us the impression here that it's not working because it's not learning the MAC addresses. Well, remember, a frame has to be received. So here we are. Let's jump onto PC1, and the IP of PC1 is 10.10.10.10. And we're going to sneak over here to the desktop, and then to the command line, and we're going to ping 10.10.10.11, and that is PC2. And as you can see, the pings are working. We're not having any issues. So now when I come to switch 1, and I'm assuming, let me stick with the plan here. Okay, so before we do that, it says attach the rogue laptop to any unused port, and notice that the link lights are red. So before we do that, let me go ahead and say do show run. What do you see that's different here? Yeah, we now have this entry for the switch port port security MAC address sticky that's listing the MAC address. And I have to admit that I'm 99% certain that on real Cisco switches, you do not get a net new line. So you see how we have that MAC address sticky here, but then we have this other line here. I'm 99% certain that that is not what you are going to see. In fact, let me very quickly here, because I have a number of switches that are connected. Let's connect up really quick to a switch that I have here. I have a 3560G that's running 15 code, and I am running port security on that, and it looks like it's going to take a second. Okay, here we go. And so it is Evil Command Center switch 1. And I want to make sure that I'm accurate on what I'm telling you, that it's not going to show you that net new second line. And while we're waiting for that secure CRT to sort itself out, we'll come back over here and we'll move on, and then we'll definitely go back and take a look. So verify that port security is enabled and the MAC address of PC1 and PC2 were added to the running config, and they are. So attach the rogue laptop to any unused switch port. So here's the unrogue laptop, or here's the here's the rogue laptop, and give me a second here. Let's say, all right, so here we are on the switch. Let me do a quick show run interface, gigabit Ethernet. Let's do 013. And I should have picked a port where something is plugged in. And I was mistaken. So you do end up with a net new line. I just simply didn't remember that. I'm not sure if that was something maybe I had seen at 12 code, but you do end up with a net new line, right? So there is your net new line. All right, so let's now attach the rogue laptop. So how do we do that? Well, we click on the lightning bolt here. That's our connections, and we're simply going to choose a copper straight through cable. We'll hook it up to the fast Ethernet port, which is the only one we can use, and then let's connect it to simply fast Ethernet 03. Now, the lights are red. The reason that the lights are red is because the ports are shut down. So now it says enable the port and verify that the rogue laptop can ping PC1 and PC2. So let's get an interface fast Ethernet 03, and let's say no shut. Now, remember, no port security has been set up on the rogue laptop. So let's bring the rogue laptop up. We'll go to the desktop. We're going to go here, and we're going to wait a couple of seconds, and we're going to ping 10.10.10.10. So we're going to go ahead and we're going to ping PC1. In fact, if I ping now, why is it not going to work? Yeah, because we're waiting here. You can see the port is orange, right? Think of that as like, the green light, red light, yellow light. Think of the orange as like the yellow light. And actually, it went green and we got a few pings through. But that orange is spanning tree on the switch, transitioning from the down state to the listening state to the learning state and then to the forwarding state. And that's why we're waiting there. So we can ping PC1. Can I ping PC2? And I can, and everything works great. So now it's saying disconnect PC2 and connect rogue laptop to PC2's port. Verify the rogue laptop is unable to ping PC1. And so here's what's going to happen. So they want us to go ahead and disconnect PC2 from its port. Now that I've done that, let me confirm what port PC2 was in. All right, so they did it so that it made sense. It was a commonsensical approach. PC1 is fast Ethernet 01. PC2 is fast Ethernet 02. So PC2 is down. So now I'm going to go ahead and do this. We're going to click on the X here, and I'm going to delete the rogue laptop's Ethernet connection into fast Ethernet 03. I'm going to come back down here to connections, and what I did right before that was I clicked right here because it gives me the arrow back. We're going to do a copper straight through, and I'm going to say rogue laptop, you're going to go from fast Ethernet on yours to fast Ethernet 02. Now, I'll be interested to see if it shuts the port down immediately or if we have to generate a ping here. So let's see what we've got. So disconnect the PC and connect the rogue laptop to PC2's port. Verify that the rogue laptop is unable to ping PC1. So let's come over here first, and you can see it says the port is changed to up. If I say do show run, There's fast Ethernet 02. Switch port security is in play, and that is the layer 2 physical MAC address on PC2. And so by default, we're only allowing a single MAC address to show up on this port, to be learned on this port. And if we exceed that, which we will when the second address shows up, which is going to be the rogue laptop, if we exceed that, that is going to trigger a violation. And then the violation is to restrict. So it's not going to shut the port down, right? Because we have restrict chosen. It's simply going to drop the traffic from the unknown host. And these are layer 2 frames that are showing up on this port, on port fast Ethernet 02, that do not have a source MAC address of 0001 64 7 Charlie 69 7 Echo. So let's go ahead and ping from the rogue laptop. Let's try to ping PC1 10 10 10 10, and I hit enter and take a look at what happens. Now you'll notice that the port stays green. The port is still up. However, what's happening with all of these ping requests? That a few minutes ago were working without issue. Exactly. They're no longer working because the switch is looking at the source MAC address of the layer 2 frames, that 48-bit MAC address, and it's inspecting it, and it's saying, if it's not that value right there, I have a violation that's occurring, and I am going to restrict that traffic. In fact, all traffic not coming from that MAC address is going to be restricted. In other words, I'm going to be generating a message, a syslog message, and I'm dropping the traffic from the bad actor, who is our rogue laptop. Now, display the port security violation for the port rogue laptop is connected to. So how do we do that? We say do show switch port security. And let's see, is it not like that? Let's do this. Show switch port. It's not doing the, sorry, switch port security. And, oh, show is it interface switch port security? I apologize if I'm messing this command up. I'm 99% sure that that is the right command. I'm forgetting my commands here. Oops, sorry. So let's say show switch port, or so switch port security. Is that what it is? All right, so I've got the wrong command. I could have sworn it was show port security. I apologize. Forgot the command. So show port security. All right, so we've got fast Ethernet 01 and 02, and you can see it's showing security action, the security count violation. So there are the 4 ping packets. In fact, if I come back over here and I run this again, and we're going to have 4 ping packets go out, if I run that show port security command, you can see that it should ultimately increase, I would think, to 8 is what I think we're going to see it stop at, because it should be sending 4 ping packets. And there we go. So we're at 8, right? So show port security. All right. And disconnect rogue laptop and reconnect PC2. So we'll come up here. We are going to disconnect the rogue laptop. I'm going to come down here. We're going to click on the connection. We're going to go to fast Ethernet 0 and then fast Ethernet 02. Now remember, the port was not shut down, right? The port was not, port was not shut down. It was simply put in a restrict violation mode. So now when PC2 is plugged back in, what's going to happen? Are we going to automatically be able to ping PC2 without any issues? And so we're still orange there. I'll kick this off, and there we go. We've got green. So what's going to happen? The first request timed out, but then we're good to go, right? So why is PC2 able to ping? And actually, I should have said PC2. I could have pinged from PC2 as well. So if we grab our desktop here and say ping 10.10.10.10, and it pings just fine. So we disconnected the rogue laptop, we reconnected PC2, and we verified that PC2 can ping PC1. So why is PC2 able to ping PC1, but the rogue laptop is not? It's because of switch port security. Because as each and every frame shows up on port Fast Ethernet 02, the switch is examining the source MAC address of that frame. And if it does not match that value, which is supposed to be globally unique and only found on PC2, then it's going to say we have a violation, and it's going to drop the traffic from the unknown host, and it's going to generate a log message. In fact, let's see if we get anything here. Actually, logging's not configured, so we don't see anything. But you would end up with a log message. A trap would get generated with restrict set. That way, if you were monitoring with SolarWinds or What's Up Gold or whatever kind of enterprise monitoring tool you're working with, you could see that, hey, we just had some sort of a port security violation. All right. Well, that is going to wrap up our introduction into switch port security and how we can secure layer 2 devices. All right. Thanks so much for watching, and I hope to see you in the next video.